Good morning, students, and welcome to Kinetic High School and Junior College. Children, we have already started with our revision, right? Today, we shall be doing our revision number 2. So, let's begin. Revision number 2. Question number 1. Give scientific reason. When an object falls freely to the ground, its acceleration is uniform. Answer. When an object falls freely to the ground, it is under the effect of constant force known as force of gravity. No other forces acts on it. Hence, from Newton's second law of motion, we can say that this constant force of gravity accelerates the freely falling object uniformly. This uniform acceleration is known as acceleration due to gravity, which acts towards the center and is denoted by G. Okay? You have to learn this answer. Second give reason. The velocity of an object at rest is considered to be uniform. Answer. Velocity of an object is said to be uniform when its speed and direction does not change. The object at rest has uniform speed of 0 all the time and does not even change the direction. Hence, the velocity of an object at rest is considered to be uniform. Understood, children? The third one, it is easier to stop a tennis ball as compared to a cricket ball when both are traveling with the same velocity. Answer. Momentum of a body is the product of its mass and velocity. So what is the formula for momentum? P is equals to m into v. And the rate of change of momentum of a body is equal to the force applied. That is, F is equals to m into bracket v minus u upon t. Now in the given information, children, both the balls move with the same velocity and finally stops. Thus, force applied to stop the ball will be directly proportional to the mass of the ball, isn't it? So F is directly proportional to m. As the mass of cricket ball is greater than the tennis ball, its momentum will be more than the tennis ball. Thus, greater force will be required to stop the cricket ball as compared to that of tennis ball. Okay? Next, question number 2. Answer the following questions. Why is the work done on an object moving with uniform motion 0? Let's see the answer. Work done on an object is given as W is equal to F into S cos theta. In a circular motion, the direction of force acting on the object is radially inwards, and the direction of motion of the object is tangential to the circular path at every instant of time. Thus, the angle theta between the force vector and displacement vector is always 90 degree. That is, theta is equals to 90 degree. Hence, W is equals to F into S cos 90, which is equals to 0. Hence, work done on an object moving in a uniform circular motion is 0. Okay? Second question. If an object has 0 momentum, does it have kinetic energy? Explain your answer. Answer. Momentum of an object is P is equals to mv. We know this, right? if P is equals to 0. So V is equal to 0. This is because the object can never be 0. Now kinetic energy of the object K is equals to 1 upon 2 mv square. Since V is 0, so kinetic energy will be 0. Hence, when the object has 0 momentum, its kinetic energy is also 0. Got it, children? Let's move to the next question. Differentiate between uniform and non-uniform motion. Let's see the first point of uniform motion. When an object covers equal distance in equal time interval, it is said to be uniform motion, right? And when an object covers unequal distance in equal time interval, it is said to be non-uniform motion. The second point, the distance time graph obtained in case of uniform motion is always a straight line, and the distance time graph obtained in case of non-uniform motion can be of any shape depending on how the acceleration changes with time. Okay? Now, example of uniform motion is a car running on a straight road without any change in its speed. An example of non-uniform motion is a car running on a road with different speeds in different time interval. Okay, children? Got it? Let's see the second, potential energy and kinetic energy. First point in potential energy. It is possessed by a body by virtue of its configuration and position. Kinetic energy. It is possessed by a body by virtue of its motion. For example, in potential energy, a book kept on a shelf has potential energy, isn't it? And example of kinetic energy, a moving car possesses kinetic energy. Got it? Let's move to the next question. Prove that the kinetic energy of a freely falling object on reaching the ground is nothing but the transformation of its initial potential energy. Answer. Let the object be at point A, that is at height h above the surface of the earth as shown in the figure below. You need to draw this figure also, children. So what happens at point A? The object is stationary, that is its initial velocity u is 0. So kinetic energy will be 1 upon 2 mv square, that is 1 upon 2 mu square, which is 0. Potential energy, that is u, is mgh. Let this be equation number 1. Now what happens at point B? The velocity of the object vb, and the object has fallen through distance x. Now using third equation of motion, we have vb square is equals to 0 plus 2gx. Therefore, vb square is 2gx, right? Kinetic energy K is equals to 1 upon 2 mvb square, which is equals to mgx. Therefore, potential energy U is equals to mg into bracket h minus x. Let this be equation 2. At point C, the velocity of the object B, vc, and the object has fallen through a distance h. Using third equation of motion, we have vc square is equals to 0 plus 2gh, which is equals to 2gh. Kinetic energy 1 upon 2 mvc square, which is equal to mgh. Let this be equation number 3. Potential energy, that is U, is 0. So children, from 1 and 3 we see that Potential energy of the object at point A has transformed to its kinetic energy at point C. Thus, it can be concluded that kinetic energy of a freely falling object on reaching the ground is nothing but the transformation of its initial potential energy. I hope you understood this, children. Now, these are some numericals which you need to practice. First one, an object moves 18 meters in the first 3 seconds, 22 meters in the next 3 seconds, and 14 meter in the last 3 seconds. What is its average speed? Very simple, children. What is the formula? Average speed is equals to total distance upon total time. So what are the distances covered? 18 plus 22 plus 14 upon the total time 3 plus 3 plus 3. What we get? 54 upon 9. After calculating, we get 6 meter per second is the average speed. Okay? The second one. An object of mass 16 kg is moving with an acceleration of 3 meter per second square. Calculate the applied force if the same force is applied on an object of mass 24 kg. How much will be the acceleration? So let's see. Mass is 16 kg. Acceleration is 3 meter per second square. So what is the formula for force? It is mass into acceleration. So 16 into 3 gives us 48 Newton. This is our force. Now we have force which is 48 N and mass which is 24 kg. So F is equals to ma, right? We need to find acceleration. So 48 is equals to 24 into A. So therefore A is equals to 48 upon 24. Therefore we get our acceleration 2 meter per second square. I hope, children, every one of you have understood today's revision. Children, please write this revision in your book. Okay, it will help you to get a good score in your unit tests. I wish best of luck for your unit exam. Children, kindly do watch the video attentively and then please write the revision in your book. Okay? Thank you, children. And once again, I wish best of luck.